Morning guys, today we're going to talk about transformation. So this is how we take a graph and shift it on a 4-quadrant coordinate grid. We first have our parent function. So we have a linear function which goes through the origin. It's a straight line. We have a quadratic, which is a parabola or a U shape, and it falls and then rises. And then we have an exponential function, which is kind of starts off small and then shoots up there, okay? First one we're gonna look at is linear. So here we have a linear equation. F of x equals x is our parent function, so this is the original. In our table we have x, which is -1, 0, 1, 2. F of x equals x is -1, 0, 1, 2. So what does that look like? It just looks like a straight line going through the origin. It goes through 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, -2, -3, -3, -4, -4, and so on and so forth. So first one is f of x equals x plus 2. What does this do to the graph? Let's fill in the table. F of x equals x plus 2. We're literally just taking all of the, so -1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. We then end up with our line from our parent function. We actually shift up 2. So shifts vertically up 2 units. You need to know that wording. Vertically means top to bottom. So if it's shifting up or down, you say shifts vertically. If it is moving left to right, that's horizontally. Get rid of those. And technically all we're doing is changing the y-intercept to shift the graph horizontally or vertically. For these, we're not really doing much else. So let's take another look at another example. F of x, x minus 3. This will shift the graph vertically down 3 units. So instead of being at -1, we're now at -4. Instead of being at 0, we're at -3, 1, -2, 2, -1. So go to your original and shift down 3 units. Always read transformations from the parent function. So if they just ask you f of x equals x minus 8, how did the graph move? You have to just assume that they mean from the parent function. So the original was f of x equals x, and it would shift down 8 units. And that's all there is to that. So linear continued. Again, we just go through the origin. Let's look at f of x equals 2x. So what happens when you change the slope? Because the slope of the original is just 1. There's an invisible 1 next to that x. Now we've changed it to 2. So the graph becomes steeper. There's our table. So -2, 0, 2, 4 are our new y values. And it just it got steeper. Let's look at another example. F of x equals 1/2 x. On the last one, the slope was bigger than 1, so we figured it got steeper. So now that it's smaller than 1, we are assuming that it's gonna get less steep. So graph becomes less steep. -1/2, 0, 1/2, and 1 are our new coordinate points, and it gets less steep. Let's look at a quadratic, and this will actually be our last one for right now. Our parent function is f of x equals x squared. New is f of x equals x squared plus 4. We are just gonna shift this up 4 units. So it vertically shifted up 4 units. And our new y coordinates are 5, 4, 5, 8. Okay? And that is all you're doing. You're just explaining what happened. And you will be doing this in a calculator. I'm gonna share another video with you on, if you're virtual, over how to use the calculator. And if you're in class, I'm just gonna show you in class. So good luck, guys.